Hi, everybody. Thanks for attending today. Today, we're going to talk about designing adhered masonry veneer. This is a copyrighted presentation, and that means pretty much nothing to anybody, so I'm going to go through this slide. Today, what we're going to talk about, and it's probably the most important part of this presentation, is we want to present the differences between a cavity wall and an adhered masonry veneer. And we want to try to explain basically how we can make an adhered veneer that does not typically have an airspace perform more like a cavity wall. We're going to also discuss some typical issues with poor installation. We're going to cover some products, little details on the products that are important as an installer, and we're going to also talk about a few things that have been lessons learned over the years. Basically, when a specification is written, whether you design it yourself and you want to make sure it's the way you expect it, or when a designer writes a specification, the performance of the wall is pretty much figured out the way they want it. Now, the way that works is sometimes you don't know what crew is going to do the work. So you want to make sure no matter what products are used, no matter who does the work, gives you the same result. And today we're going to talk a little bit about that. We're also going to talk about how to make sure your adhered veneers are going to last a long time and giving you the installation you expect. Basically, a cavity wall has an airspace. We're all familiar with this in the masonry that we do. And the airspace in the cavity allows for air and vapor and moisture to move freely and down to the weeps and basically back through the mortar joints. And if you have a weep at the top of the wall, it'll allow for the chimney effect to work that way. How a cavity wall functions is basically moisture comes in through the squiggly arrows that you see, drains down for the most part, and out through the weeps. Adhered masonry veneer, though, doesn't have any sort of way to breathe from the backside. You have your sheathing, your moisture resistant barriers or weather resistant barriers, which we'll call WRB for this presentation. And the metal lath is typically directly in contact with the second layer of WRB. It's usually encapsulated with a brown coat, scratch coat, or base coat of mortar, whatever you choose to call it. It's the first coat that encapsulates the wire lath. And basically, if it gets saturated, your sheathing can end up ultimately becoming saturated. The picture on the right is kind of a nice picture. Whenever you do an adhered masonry veneer, anytime you can do it from the top down, you will have a better looking project. The reason why is because your bigger units will be at the top. They're not going to be cut so small that you're trying to fit them in. They'll be more of your primary units. Also, you won't have mortar droppings that go all the way down and start to accumulate that have to be cleaned. And if you're using a cultured stone with a finish that's put on in a factory, you don't have risk of washing that finish off. Adhered masonry veneer wall design basically typically consists of a natural thin stone, thin brick, which is actually a sawn brick unit, and cultured stone, which is actually concrete units that appear as stone. The veneer units, as well as the mortar joints, can either be grouted or dry stacked, which will allow water to basically be absorbed into the scratch coat. And water can then go into the structure through voids, whether it be screw holes, non-taped joints. Basically, there's a lot of paths for water to penetrate. So when that happens, the question becomes, how does your wall dry? Well, your wall's going to dry through your mortar joints typically. If you have open joints, they're going to dry through the open joints. If you have mortar joints, they're still going to dry through the mortar joints. Sometimes moisture can go down through the scratch coat and get down to the weep screed, but a lot of times it doesn't make it that far. It just basically goes through those head joints. One thing to think about is if you have a fully saturated adhered veneer, for every inch of thickness, you're going to have, depending on what side of the wall is exposed, north, south, east, or west to the sun, and what temperature time of the year it is, but you're going to have about 35 to 40 days for every inch of material that is thickness for it to dry. And that's assuming that you don't have a rain event in that time to re-add water to the veneer. And that's kind of an important thing to think about, is because if you can't dry faster than that, you need another way to make sure you get dry. So let's go ahead and take a look at the next one. Adhered masonry walls basically only can dry through the mortar joints and through the down to the weep screed. And this becomes sensitive because as that scratch coat is saturated, it allows for direct contact to the outer layer of WRB and ultimately to the sheathing. Because it's so much slower, that moisture is going to sit there longer, and it's going to have a longer time to find penetrations into that sheathing. If you were able to put something in the place like a drainage mesh, you would then be able to increase in the drying at a more rapid rate. But at this time, it's pretty slow. Oops, apologize for that. Here's a quick little video that's going to explain what a drainage plane does before we get into it any further, and it'll allow you to see exactly where we're going with this.
In this video, we're demonstrating the drainage capabilities of 3 different stucco wall sections constructed using common stucco wall configurations. We wanted to see which of them would drain the quickest and most completely. Research by Dr. Joe Stadurek of Building Science Corporation, among others, has proven that adhered masonry walls with a 1/4-inch drainage plane stay significantly drier and are less prone to water damage and mold than walls built the traditional way of attaching self-furring lath directly on top of the weather-resistant barrier. Unless adequate drainage and ventilation are provided, mold, rusting of steel components such as fasteners and lath, and wall failure can occur. Each wall section consists of a solid backing with a 2.5-pound galvanized self-furred expanded metal lath attached to it, and 3-coat hard stucco applied to the lath using standard stucco application techniques to guarantee full lath encapsulation. On wall number 1, the lath is attached directly on top of Owens Corning Foamular extruded polystyrene rigid insulation, the surface of which is a water barrier. Wall number 2 also has the same rigid insulation, plus it has 2 layers of standard number 15 asphalt paper over the insulation, with the lath attached on top of the paper. This is the most common stucco wall configuration used today. Wall number 3 has a clear acrylic back so we can see through it. Lathnet, a factory assembled combination of a galvanized 2.5-pound self-furring expanded metal lath and a 1/4-inch thick drainage and ventilation mesh, is attached directly to the acrylic with no insulation or paper. Lathnet is the only system in the 3 demonstration walls that includes an integrated drainage plane to provide both drainage and unobstructed air circulation to promote rapid drying. Because of its proven benefits, installing a drainage plane behind all forms of adhered masonry, including stucco, is becoming increasingly common. For the demonstration, we placed on top of this water collection apparatus. We poured water into the troughs at the top of each wall, which funneled the water behind the stucco. Any water that ran out of the wall was captured by this trough and collected. In test wall number 1, water was only able to drain very slowly through one spot. In addition, water trapped behind the stucco saturated the stucco to the point where the water migrated to the surface. In test wall number 2, water was able to drain slightly more rapidly from behind the stucco than in wall number 1, but only from a few locations. There is no space created between the stucco and the weather-resistant barrier to support ventilation. The third wall with the Lathnet drainage plane behind the stucco drained very rapidly across the entire width of the wall section. We turn the wall around to make the water flow visible through the acrylic, and you can see that almost all of the water runs through the drainage mat very quickly. Glass net is the only available factory-assembled combination of expanded metal lath and a mesh drainage plane. It uses familiar tri-layered materials to provide rapid and complete drainage, and it provides an airspace between the weather-resistant barrier and the scratch coat to allow air movement and drying. To request a product sample, email samples@mortimer.com or call 219-850-4509.
Okay. Basically, the adhered masonry veneers that incorporate drainage can be compared to a cavity wall in a sense because they both use space that allows for air, water, and vapor movement behind the outer veneer of the wall. As we just saw, basically you can see how rapid, if you were to have as much as a cup of water, could go down through a small area like that. That was extreme, but the principles are the same. This occurs when an entangled or a high loft non-woven drainage mesh are used. They're made of polyester or polypropylene. Those are the two mesh types available on the market. They both perform very, very well. Neither one is preferred by one or the other. And they're basically placed between the WRB and the scratch coat. Both mesh products will prohibit mortar from entering the drainage base and yet allow for full encapsulation of mortar surrounding the wire lath. The ability for the air, vapor, water to move basically unrestricted behind the scratch coat was clearly shown in the video. The benefit to the substrate walls is simple. The moisture is going to move behind the scratch coat, in between the scratch coat and the substrate, much faster with less time for direct contact, which means less time for it to find the voids to enter your wall and create these types of situations. The addition of drainage mesh in an adhered masonry veneer wall is not a new concept. Based on several years of testing, the MVMA, Masonry Veneer Manufacturers Association, which is part of the NCMA, National Concrete Masonry Association, has allowed, when using a drainage plane, to reduce one layer of weather-resistant barrier, or WRB, and this is going to simplify a lot of failures, because what happens is when you use the drainage mesh, you're going to get the drainage, you're going to also get a simpler application, and you don't have to tape it, you don't have to worry about the penetrations, because typically they're going to be put in when you put in the wire mesh. Of course, the reduction of one WRB layer is going to be dependent on your local code official's final word. But typically the IBC, when used on that size commercial project, will allow that to happen. Deterioration between a majority of masonry adhered walls is not common by any means. But here is a couple of examples of what happens when they do fail. When they do fail, moisture gets in, typically in localized areas, and it cannot be found until it's too late. As you can see, the insulation is still pretty clean on both of these pictures, so the homeowner was not really aware of what was going on these pictures. There's a failure on the left-hand picture that's different from the right-hand picture here. If moisture was able to drain out of this system at a rapid rate during cold weather, you wouldn't have had the spalling that is shown. The spalling shows where the brick basically pops off because the scratch coat stayed very wet and allowed for the expansion of the moisture. If drainage was to occur in behind, that would have dried faster, allowing for a more secure bond and a better bond and better scratch coat all in all. What makes this picture really bad is it's over a window, so you know you're going to get moisture into the building at a pretty good rate when you have this type of failure. Other thing is, this repair cannot be repaired locally. It's going to have to be stripped off, the scratch coat's going to have to be removed, and the WRB and or the sheathing may have to be repaired as shown in the picture before. Picture on the right's a little different. They had an indication that the chipboard was starting to swell and was wet and had some mold. The one on the right was able to be actually repaired locally before it got way out of hand. Now there's a summary of some products that need to be discussed here that'll help you in doing your installation. Weep screed. It's a product that is not mandatory. However, weep screed is typically a galvanized metal or a durable plastic strip placed at the base of the wall. It's usually 3.5 inches tall, and it's always fastened to a stud, or if it's concrete, back up into the concrete block. This product is, again, not mandatory, but is really worth the effort and the expense. It's not very expensive, but what it does is, as you can see the holes in the lip, that allows the moisture that comes down through the scratch coat and from the drainage plane a place to weep out. A weep screed is not considered a weep. It offers a place for moisture to weep out. I know it sounds kind of technical, but that's how the NCMA wants it presented. A weep screed is always important because it gives a clean line, but it does not support the masonry. The bond of the material to the scratch coat is what supports the masonry. The back lip of the weep screed always has to have the drainage plane come down to the bend out, and also your weather resistant barriers. Otherwise, the nail holes will allow for water to pass into the sill plate and create deterioration that can never be found once the veneer is placed. Whoops. The weep screed must be placed a minimum of 4 inches above grade and 2 inches above the roof line. Alterations to these dimensions will get you in trouble. The reason why it's so important above the roof line is because, say it's your house and 15 years from now you want to redo your roof. Your step flashing is going to have to be evaluated, and if you have to take veneer off in order to do your step flashing on your residential house, that's going to be ridiculous. So just raise it up 2 inches and you should be fine. As far as that grade, it's really important that the person responsible for maintaining the building respects the veneer. If you're going to have landscaping, sprinklers, snow, gutter discharge, any kind of splash hitting the base veneer, you're going to have problems. In climates that freeze, you will have pop-off. In places where you used a cultured stone with a manufactured finish, you're not going to be able to clean that stone like you would a natural stone product. What will happen is the finish will come off over time. So it's very, very important to place the base of your veneer high enough above grade that it'll perform well for years to come. Weather-resistant barriers. They're there to shed the moisture that passes through the veneer away from the substrate. That's all they do. This is a zip wall system, but let's talk about a weather-resistant barrier where there's 2 weather-resistant barrier planes put on. The first one's typically done by the framing contractor. Framing contractor gets it nice and tight, and that's going to allow the framing to stay dry during construction. It's also going to assist them in getting dried in faster for the homeowner. The second layer is usually put on by the adhered veneer masonry contractor, and that is to keep everything dry during the setting of the scratch coat. A long time ago, and I'm old enough to remember that, number 15 felt was used, but it was 15-pound felt. There's also 30-pound felt. Well, now it's number 15 felt and it's number 30 felt. Number 15-pound felt can be anywhere from 15 to 13 pounds. It's no longer 15. And a lot of people still use it as a weather-resistant barrier. It's not my first choice, but the reason I say this is because depending on what you spend on your number 15 felt, you can either have a little bit of success or a little less success. Commercial air and water barriers, both roller applied and membrane, are also used under adhered masonry veneers, and they perform very well with no issues. There's no reason to pick one over the other. Continuous installation or rigid installation has become increasingly popular with adhered veneers. When a veneer is placed on the exterior side of the insulation, it is allowed as a non-engineered system for foams that are half-inch thick. Foams that are a half-inch or greater will require an engineered anchoring system, but that's not a big deal either because there's companies out there that sell the engineered systems off the shelf. Specialty washers, they look like a gimmick, but they're not. They're really worth the effort because they will hold everything in place, excuse me, and give you a watertight seal with every anchor. Lath. Lath is extruded wire. It's available in 3 weights: 1.75, 2.5, and 3.4 pounds per square yard. The 1.75 should never, ever, ever be used on the exterior of a building. If you're doing a restaurant and you're doing a 4-foot high wall, that's when you can use it. But other than that, the 2.5 and the 3.4 are your lath. They're both galvanized G60, and which means they're going to hold up under anything that the North America climate wants to throw at it. It's placed 1/4 inch out from the substrate to allow for the encapsulation of the mortar. And the scratch coat, base coat, brown coat, they're all the same. Has to basically be put in 1 to 2 to 3 different press levels. You're going to basically come up from the bottom in most cases, is traditional, and you're going to go over it 3 times to make sure you fully encapsulate that wire. Installation of metal lath is really important. Steps taken to make sure you have a tight-fitting metal lath installation are every bit worth all of your efforts. It's important, very important, that you get your wire level at the first course and attach it properly. Your weep screed is always going to be placed before your wire lath. And what you want to do is make sure you never, ever, ever fasten in between studs. So I make the rule that you're going to go 6 inches, not 7, vertically at every stud and never in between a stud, because what will happen is that will pop out over time. Lath can terminate at an inside corner, but it can't at an outside corner unless you're going to use specialty products. So you have to turn the corners 12 inches each way for the proper lath attachment. Cutting is really easy. For those in the trade, always use the red tin snips. They cut to the right. That's going to give your hand a lot better chance of not coming out as bloody mess. And the cutting shears that you can put on your drills have actually become the primary way to cut it. They're very efficient. You can do it with a battery operated drill, and it's going to give you a good job. All current lath systems, whether it be paperback or LathNet, the product that's shown here in this picture, they come with an overlap, which offers the contractor the ability to quickly install with a shingle design. Now, a shingle design is when you put the first piece down, second piece just overlaps the top, which gives you your proper mesh to mesh joint. It also allows for the overlap of your wire lath so that you can be code compliant. When you're using a lath system, paperback lath is typically hot glued to the lath. And unfortunately, in cold weather, wet weather, and hot weather, it can come apart. LathNet is going to be mechanically fastened and can be stored underwater for all it matters. It won't have any effect on it coming apart. When you're installing the 2 products at the same time, you're going to reduce penetrations by approximately 50% because everything's done in one application. And the shingle design will allow the overlap each time the way you need it, reducing any stress that your guys can be putting it up wrong. Metal lath systems can incorporate the products that we just talked about. Most of your lath is going to be the 2.5, and most of your mesh is going to be a 1/4 inch thick. And that's all you need. So it's very important that you don't allow a product to be 3/4 of an inch of mesh behind your lath. It's overkill. It's money not well spent. Plus, it's not going to give you the strength in your anchoring that you need. Oh, one more thing. When you use a lath system, your fastening techniques for your metal lath will be the same whether you're using a system or parts pieces. Fasteners. The allowable non-corrosive or corrosive resistant anchors used for the following anchor systems for lath are as follows. If you're doing a wood frame, you can still use staples, roofing nails, and screws. The minimum design is 3/4 of an inch for embedment. However, based on many years of experience, I would always recommend 1 inch across the board as a good practice. If you're doing steel stud, the only recommended anchor I can offer is the self-tapping screw or the hex head anchor. And if you can use a neoprene washer, please do. Make it attached to the anchor when you buy it. The minimum embedment for this anchor would be 3/8 of an inch. But again, if you went deeper, it would give you better odds for success. Now, concrete and concrete masonry units, I still like to do my pilot hole and use a fastener, a tech screw or something like that. The MVMA does allow for powder actuated fasteners. Now, they're also known as cap anchors to some of the older guys. Powder actuated anchors, they don't need a pilot hole. They're easy to install. You basically put the gun up there and boom, it's done. You can't monitor how tight they go. You can't monitor if you're blowing out the back of the block. That's why I don't like it. But they are allowed to be used. They are very economical. Scratch coat. Scratch coat should be put on the wall after you inspect your WRB and your weep screed before you begin your work. Any loose edges, any bulges, any puffy areas in your wire should be tightened up. When you're applying your base coat on your lath that has been in direct sunlight and is hot to the touch, use a spray bottle to cool the metal off before you apply the mortar. That is going to save you a lot of problems, because what will happen is with the hot metal, it'll pull the moisture out and it'll create a weaker scratch coat. On windy days, when you complete your base coat application, cover your work with plastic. You probably, unless you're pumping it, you can afford the plastic. It's going to save you the money down the road later. It's going to slow the evaporation, and it's going to allow the proper drying for the mortar. And on high temperature days, like we've been having here down where I live, misting the base coat during the drying will prevent a whole bunch of cracking. It's really important that you do these things. They sound like they're just textbook, but they really do change the performance of what you're doing. One of the things I like to do, and I do a lot of stone installation myself, is when I'm scratching it, it's like a little garden rake. I'm cutting grooves in, as you can see in the photograph here. And what happens is that increases the surface area for your bonding of your units. Well, every once in a while, I like to put a vertical scratch and a horizontal scratch on a level and a vertical plumb so that I can use that as reference when I'm laying my stone. For instance, if I'm laying a stone that's got a rounded top or even a ledge stone, sometimes you can get that wall to weave up and down just a little bit. And as you step back from it, you can see it. But while you're laying it, you can't. If you had every once in a while a leveled scratch, you could then use it for reference, and it really helps you do a better job. Setting of the veneer units. This is the fun part. When you actually get time to set the units, you're going to butter completely. There's no void on the back of the stone. There's no exposed stone on the back side. You're going to butter that thing all the way around and in the middle. And when you place your hand on it, you're going to put it into place. You're going to do a little left, a little right, and then you're going to press it. If it doesn't stick, your mortar's not right, or your modifier's not right. Modifier being latex or a polymer or something. You didn't do something right with your mortar. That should stick perfectly when you do it. That's why you're able to go from the top down, because it's going to stick. Here's a part of this presentation that is for reference. It's not the kind of thing that you're going to want to remember, but you want to know where it is when you need it. I've been in the trades. I worked as an engineer early in my career, and now I'm on the manufacturing side. And one thing I can't stand is when somebody says, yeah, well, we're ASTM such a number. Well, nobody has all these numbers in their minds. But what they do know is they know where to find them when they need them. So what I did here was I kind of outlined what each different manufacturing association or industry association does, so that you know where to go if you have a problem and you have to figure it out. So the Masonry Veneer Manufacturers Association basically provides the guidance and design for manufacturing units. It's a free download. It is the best manual you can get for anyone who is working with adhered masonry veneers. It follows the ASTM C1780. It's in the 4th edition, and it's in the 2nd printing, and is by far the most valuable download you can get off the internet if you're doing adhered masonry veneer. The International Code Council, everybody hears about this, the ICCES, and all they do is they provide acceptance criteria for industry products through evaluating and testing. You can have a product that's ICCES approved, and that's all it is. It's just approved. So sometimes people misuse this, and it's really a good thing to know what they actually do. The IBC, it's the governing code that recognizes minimum requirements of a building product. The IBC does not govern single-family townhomes up to 3 stories, single-family, or duplex construction. Now, the ASTMs I'm going to cover here, again, are only so you know where to find this information if you need it. If you're a contractor and you have a problem, you want to go to an ASTM to find out what rights you have, what you've done correctly, what you may have done incorrectly. The ASTMs are valuable for the contractor to know where to find them, but at $50 a piece, before you go buy a whole bunch of them, it's nice to know which one you need. If you go to the ASTM website, you can get a paragraph or two of what each ASTM stands for. But here what I've done is I've given you the most important ones to save you that time if you ever were to have a problem. For instance, 1063. This standard it's broad to the industry, referring to suspended ceilings, hangers, runners, attachments, but where it's important to you is with nails, screws, and weak screed placements. It's useful in the do's and don'ts of lath placement. That's what that standard will help you with. 1384. It's a standard that discusses additives and admixtures that are combined with conventional mortars. If you're adding latex to your mortar, this is the one you want to read before you do it, because this is going to give you all the ups and downs of what you're doing, right or wrong. This standard is important for the consistent quality in the manufacturing of cementous stone veneer units. So if you're having a problem with your supplier, your units are not coming out the way you want them, this is the one you need to read to see what you can do. C270, that's an important one. That's basically the basis for determining the properties and testing of your mortar used in reinforced and non-reinforced construction of unit masonry. That's a very common standard that most people already have a hold of. 874. This specification is when lath is used with Portland cement, plaster, or adhered veneers. The standard discusses the different types of lath available, both with and without backing materials. So if you're having a problem with your lath, if you're having a problem with it bulging, buckling, this is where you want to go start first. And 1059 and 1059M, this is a good one if you're just getting started in the industry, because it discusses latex bonding agents for applications far beyond adhered masonry veneers. It's just a really good one to have a record of. ASTM 1714 addresses the rigid measures used to maintain consistent ratios when mortars that don't fall into the category of C270. This basically is for pre-blended mortars that you will buy in a bag. You probably never need to use this one, I would think. And 1780, it basically covers what we just talked about in this whole presentation. Now, before I talk about this picture, this unit is not fully buttered. It looks like he's pretty close. Those backside of that unit will be fully encapsulated with mortar before he sets that unit. But since a specifier cannot choose a contractor that constructs a project, basically we never know which one of our competitors are going to get a job. The specifications that they write are for the way they want that job to be, and using products and systems that are going to guarantee the performance of the wall no matter who builds it, whether it's you or your competitor, which we want it to be you. We're allowing an even playing field, and we're also allowing for performance that won't get you a call back, whether 3 months down the road or 2 years down the road when the sheathing has rotted. In summary, we want all your projects to be this beautiful, and that's our goal. Does anyone have any questions?
Okay, Stephen, first question. Where do you place the drainage mat in a thin adhered veneer system?
Between the outer layer of weather-resistant barrier and the extruded metal lath.
Okay, this must be the follow-up maybe. What function does the drainage mat have on wall performance in a thin adhered veneer system?
That one would be where if you have a drainage plane, it would allow for drying of both sides of your adhered veneer or your thin veneer. It will also enhance the ability for the drainage down to the weave screed, and then it'll also give a shorter period of time that a saturated scratch coat could offer direct contact of moisture to the substrate.
Is there a rule as to when you must use polymer modified adhered veneer mortar above the 10-foot rule, question mark?
I don't have that because that would be a local code issue for wherever that is. However, anytime you're using a polymer modified mortar, which I have used, or a latex modified mortar, the enhanced bond characteristic is going to speed up your setting time tremendously. I have done it both with latex and the polymer modifieds, and the bond that you get and the ability to quickly place your units in the secure manner that you need to, it's phenomenal. It's worth every penny towards your labor that you can spend when you use those mortars.
Okay, Stephen, your next question. Does the drainage mat create airflow?
It allows for airflow. It doesn't create it. It allows, basically, as a wall gets wind, negative pressures will occur, and there will be some deflection in the veneer, and it allows for air movement. It also, just being that it's an open space, it's filled with air, allows for air movement, but it doesn't create it, no.
All right. How far is lath held of the substrate for self-furring lath?
1/4 inch.
Next question. Is there a height limit for thin veneer masonry without engineering?
That's going to, again, be a local code issue based on your environment. So if you're in a high wind area, that may change versus being here where I live in Nashville. That's a local code question.
Okay. The MVMA guidelines address when it is recommended to use the polymer modified mortars based on heights. I'm sure that's a question or a comment. Sorry.
That's a good comment. Thank you.
Absolutely. Next one. Is there an advantage for using cement board with polymer modified mortars?
In what application?
You can ask the question to them and then I can reply back.
In what application? I don't understand the application. If you're going to do an exterior application, your sheathing is going to be there. The weather resistant barrier is governed by local code, but typically cement board is not used as a standard behind adhered veneer in most applications that I have seen, and I've been across the country doing this because of the cost of the cement board. You're talking about like Durock, right?
Stephen, the follow-up is instead of wood or lath.
It would work fine. It's not a common practice. It's like building a shower with tile. It would work perfectly. That's a lot of how Laticrete does their work with that type of an application. So it would work perfectly. But typically the wood is used for like Laticrete. They use an air and vapor barrier. In a lot of cases, the membrane barriers are used, and then the adhered veneer is put on after that. There's no downside to what the question is asking. It's just not a common practice.
And he says, thank you.
Okay. Ask what location are they in that they're doing that?
No, you just asked him, so we'll wait for his reply. Minnesota.
Okay. He can feel free to contact me. I'd like to further discuss it if he's interested.
Okay, I will get his contact information and email you both.
Thank you.
Absolutely.